Hello everyone, and welcome back to the Cisco Packet Tracer Laboratory session. Today, we are going to focus on a very important switching concept called EtherChannel, specifically using the industry standard protocol known as LACP, or Link Aggregation Control Protocol. If you look at the notes on the screen, we have a specific scenario to solve today. This is case number 1. We need to enable an industry standard EtherChannel, which implies LACP, between our two switches. The requirement is quite specific. We must configure the link so that one side does not start the negotiation, while the other side actively tries to form the bundle. This means we will be setting one switch to passive mode and the other to active mode. This mismatch is actually a valid configuration in LACP. If both were passive, the link would never come up, but with one active and one passive, they will successfully negotiate a channel. Physical connections cabling. Let us begin by establishing the physical layer connectivity. Because we are connecting two devices of the same type, a switch to a switch, we need to use crossover cables. I am selecting the crossover cable from the connections menu. First, I will connect the Fast Ethernet 0/1 port on the left switch to the Fast Ethernet 0/1 port on the right switch. Next, to create redundancy, I will take another crossover cable and connect Fast Ethernet 0/2 on the left switch to Fast Ethernet 0/2 on the right switch. You will notice the link lights are currently orange. This is a spanning tree protocol, or STP, doing its job. It is listening and learning to prevent loops. Without EtherChannel, STP would eventually block one of these links to stop a loop, meaning we would lose that bandwidth. Our goal with EtherChannel is to bundle these two physical cables into one logical link, so we can use the bandwidth of both simultaneously. Configuring the left switch, switch to passive. Now, let us move to configuration. We will start with the switch on the left. I will open the command line interface. First, we need to enter privilege mode, so I type enable. Then, we enter global configuration mode by typing configure terminal or just so an FT. The first thing we must do is select the interfaces we want to bundle. It is very important to configure both ports exactly the same way to avoid errors. So, I will use the range command, interface range Fast Ethernet 0/1-2. Now that I am in the interface configuration mode for both ports, I will first set them to access mode. I am typing switch port mode access. This is a good practice to ensure the trunking negotiation doesn't interfere with our lab. Now, we apply the EtherChannel command. The syntax is channel group followed by a number. I will use group number 1. So, channel group 1 mode passive. Please pay attention to the keyword passive. In the world of LACP, passive means this switch will only listen. It is waiting for the device on the other end to send LACP packet saying, "Hello, do you want to form a channel?" If the other side stays silent, this switch will also stay silent. We can now verify this with the show commands or simply exit, as the configuration on this side is complete for now. You can see the interface port channel 1 has been created, but the line protocol is currently down because the other side is not yet configured. 3:20-5:10. Configuring the right switch, switch 3 active. Let's move to the switch on the right side to complete the circuit. We will open the CLI here as well. Just like before, we type enable to get to the hash prompt and configure terminal to start making changes. We must select the exact same ports that correspond to the other end. So, I will type interface range Fast Ethernet 0/1-2. I will also set these to access mode for consistency. Switch port mode access. If I set one side to trunk and the other to access, the EtherChannel would likely fail or go into a suspended state. So matching these settings is critical. Now comes the vital part of our LACP configuration. Remember, the left switch is passive, so it is listening. Therefore, this switch must be the one to start the conversation. I am typing command, channel group 1 mode active. Notice the keyword active. This tells the switch to actively send out LACP protocol data units, PDUs. It effectively says, I am sending negotiation packets to my neighbor. Because the neighbor is in passive mode and listening, it will hear these packets, respond, and the EtherChannel negotiation will succeed. If I had used passive on this side as well, both switches would be waiting for the other to start, and the link would never form. So, active-passive is a perfect pair. Verification and conclusion. As soon as I hit enter, watch the console messages. You can see a notification stating that port channel 1 has been created. Shortly after, we see the line protocol message changing state to up. This is a great sign. It means layer 1 and layer 2 are operational. The physical ports Fast Ethernet 01 and 0/2 are now bundled into a single logical interface called port channel 1. If you look at the topology map behind the CLI window, you will see the link lights are currently transitioning. Spanning tree is recalculating the topology. Because these two links are now seen as one single logical cable, spanning tree will not block either of them. Instead, it will forward traffic across both, giving us double the speed and redundancy. If one cable fails, the other will keep working without interruption. We have now successfully satisfied the requirements of Case 1, establishing an industry-standard LACP EtherChannel with one side active and the other passive. Thank you very much for watching this lab demonstration. I hope this clarifies how LACP negotiation works.